Welcome to Škoda Auto's brand new paint shop. Thanks to a number of innovations, it produces almost no paint waste, among other benefits. In the spray booths, they use special filters, covered with a layer of crushed limestone that work like a vacuum cleaner.
The vacuum pushes the running waste paint onto this filter which absorbs it. We bring the petrified air into the spray booth and save up to 80% of energy. Used limestone is not discarded. It is used by the local energy company Skoda and Ergo to reduce emission during flue gas desulfurization.
Let's go back to the paint shop itself. The unique 35-meter-tall building consists of 7 floors, and bodies from the body shop arrive there at a height of 14.5 meters.
The bodies undergo pre-treatment before they are painted. They are degrizzed and rinsed in a bath, and then receive a phosphate coating for better material adhesion. A new feature is that the whole body is turned around in the bath, so that there is no place left untreated. Corrosion resistance is ensured by cathephoresis in the tub with an electric current, which you can see right behind me.
Next up is the workplace, where the bottom of the body and every joint are coated with a plastisol layer so that the joints and seams are sufficiently tight. Everything is sealed and ready, and the bodies go for the filler line, where they are sprayed with paint to fill any uneven surface and to protect the cataphoresis against UV radiation.
In addition to cataphoresis and filler, we apply 2 more layers of paint: base coat and clear coat. Base coat provides the desired shade, and the clear coat is a clearer, transparent paint. The whole coating system makes the surface shiny, smooth and resistant to pebbles, UV radiation and pigeon droppings.
The biggest problems during the painting are dust and dirt. In order to achieve maximum cleanliness, an unusual material is used to clean any undesired dirt off the bodies: ostrich feathers.
The bodies also go through several drying processes. All the ovens are equipped for the thermal, after burning of waste materials. This eliminates organic substance emissions, and we use the released heat to further heat the bodies.
The transverse oven is another innovation used only by Škoda Auto all around the world. The windscreen opening and the engine compartment supply hot air to the body. The heat penetrates from the inside out, and the paint gradually dries up. Using a central heat exchanger and mixing warm air in the new ovens can save up to 20% of energy. Although these ovens are a bit wider, they are half the length of the regular ones. After the robots finish their work, human hands and eyes come in to check whether the surface is even and smooth. After the final inspection, we have a body in the customer's color of choice. What is the most efficient way to measure engine power? The Škoda Auto Engine Development Center has the answer. With state-of-the-art engine brake equipment in place, the team can test even the most powerful engines, like those used in Škoda motorsport vehicles.
After the workshop assembly, the engine is clamped onto a special device known as a pallet and fixed in a position that is identical to the one in the vehicle. The engine is brought to the test site, where it is connected to a brake, exhaust system, cooling system, fuel system and measurement equipment. That typically takes the form of temperature and pressure sensors.
The engine brake can simulate any operating conditions. The engine can be braked or turned freely, which makes it possible to test various driving conditions, from city traffic to mountain roads.
We have 15 brake sites in total, and their power ranges from 220 kilowatts to 400 kilowatts. The most powerful high dynamics brakes are used for motorsport. This is where we test engines for the Fabia R5.
The key parameters under review are engine torque and revs, but the full list of measurements contains hundreds of items, including temperature, pressure, flow rates, emissions, and of course, engine control unit data. All data are saved on a server from which engineers download for further processing and review. Two key types of tests are performed: functionality, and long-term.
Long-term tests are designed to check the expected engine lifespans. They are carried out at the development stage to test the resistance of entire engines or some of their parts, and to check that the series line installation is fail-safe.
The purpose of functionality tests is to support the process of developing new engine components and fine-tuning their performance, or setting the engine control units.
Now we are one floor higher above the test benches, where we treat the engine intake air to reach the required temperature and humidity, draw exhaust gases off the engine, and, last but not least, treat the cooling water.
The safety requirements are strict. Each test site features an automatic fire extinguishing system and detectors to identify any leaks of carbon monoxide or hydrocarbons, like petrol and methane. Engine operation would be stopped immediately in the event of a threat. By the way, the benefits of the engine tests done here are not limited to development efforts. The generated heat is recovered and reused, for example, to heat the building. The engine brakes generate electrical energy, which is supplied to the building, making it partly self-sufficient. Everything under one roof. That is what Kvasini's new quality center is all about. The distances between individual sites are really short, which makes ŠKODA vehicle testing easier and faster than before. The center is equipped to work on vehicles with conventional combustion engines, hybrid vehicles, and all-electric vehicles.
We test both pre-series and series production vehicles here. Using the most modern equipment, we are able to test vehicles by using the strict ease of criteria to give customers the highest possible quality.
Let's join the Superb IV as it goes through its rounds. 27 specialists handle about 20 vehicles per day, checking them for excellence across 5 specialized categories. These tests are conducted in addition to the series production inspection system. Using diagnostic software, the staff first check the vehicle's electrics and electronics, the individual control units, and the assistance systems, as well as other onboard electrical devices, such as air conditioning, radio, and navigation systems. The next stage is a water test.
As part of the water test, we can simulate European rain as well as monsoon's downpour, both when standing flat and on a hill.
The customer wants a dry driving experience and of course would not like to hear any unpleasant sounds. Therefore, the next stage is an acoustics chamber, in which we check the vehicle for disturbing noises and ensure that all of the vehicle seals are working properly.
We use an acoustic camera to locate operating noises. The camera graphically shows us places of increased noise, which we then analyze and determine its causes.
If everything is all right, the car goes to the chassis and powertrain site, where the staff check the chassis geometry, the settings of the onboard assistance system, the engine bay arrangement, and the headlamp direction, including the new matrix beam system.
On digital scales, we check the correct weight distribution on each axle. The car is then tested in the roller test stand in various operating modes. By adjusting the driving resistances, we can simulate the load on the drive unit and check the function of the brake system.
The roller test also checks the braking and four-wheel drive systems. Hybrids and all-electric vehicles are also checked across their individual E-modes, including recuperation. The new hall is equipped with modern testing facilities to ensure that the quality check is thorough and effective. We have completed our round through the quality center, and the car, after a rigorous inspection, is now on its way to the customer. There is a fascinating story about one of the most complex testing machines at Skoda Auto. It is called a Hydropulse, and its aim is to simulate a vehicle's journey over any surface and to verify the firmness of its bodywork and chassis during the first phases of development, or in a vehicle manufactured abroad. For example, this Kodiaq from Russia.
One of the testing circuits of an entire vehicle development is a specific part of the polygon in Germany. It corresponds to a very demanding 8,000-kilometer journey, which in customer operation equals approximately 300,000 kilometers. The vehicle being tested can complete this distance with 1 month on the polygon. But in our laboratory we are able to complete the same distance in just 130 hours.
Prior to the test itself on the simulator, the car starts its journey to the polygon with special measuring technology. It is attached to the machine upon its return from the polygon. From the measured data, with the aid of computer programs, the first testing signal is prepared, which feeds the machine and makes it possible for the test to start.
The advantage of this testing machine is a significant reduction in the amount of time that the testing takes compared with the ride on the polygon. Another advantage is that the testing takes place here in Mlada Boleslav directly inside the technical department, so we can obtain immediate feedback from an expert division.
Opakovatelnost zkoušky, kde nezáleží na vlivu počasí, na vlivu řidiče a podobně.
During the simulation, the engine and transmission are not engaged. These will be tested only later, during the subsequent journey on real terrain. After the test, the entire vehicle is disassembled and checked for any damage to the vehicle body and chassis. For vehicles that cannot be operated for various reasons, another testing condition is used, known as the vertical four-cylinder condition.
It differs from the previous one in that the tested vehicle does not have to be mobile. We use a synthetic signal, which is created by combining the worst sections measured during a driving test.
It is also possible to test the effect of climate conditions. The testing condition is equipped with a climate chamber and a simulation of the sun's rays. None of this would be possible without the core of the entire testing facility. 8 large pumps with a flow of 2,000 liters per minute and 13,000 liters of hydraulic oil.